All right, we're gonna see if we can make a good, this is our good Lewis structure for nitric acid. Meets the octet rule. And see if we can make it better. Just as a note, the nitrate ion that you've learned that has the 3 resonance structures, I'm just drawn one of them here. Looks like this, NO3, double bond, 2 single bonds. And then the way you can think about nitrate is that when you add a hydrogen to it, it becomes nitric acid. Notice where the hydrogen is. It's bonded to the oxygen, not to the central nitrogen. We need to learn that's what happens where the hydrogens go on acids. Now let's calculate the formal charge of each oxygen. Now hopefully you remember that if you have a single bonded oxygen, it's -1, double bonded is 0. This has 2 bonds, it's also 0, 0 here. What's the formal charge on this nitrogen? Yeah, I'm doing it right. Formal charge on the nitrogen has 5 valence electrons. There's no lone pairs on this one, and half of the 1, 2, 3, 4, there's 4 bonds that are there, are 8 electrons. This gives you a +1 charge. All right, good. So with this +1 charge, and I've got a -1, we're learning that in formal charge theory, if I can go ahead and make this a double bond here by moving in a set of electrons, then I can improve the formal charge structure of this and make it the best structure. And sure enough, when let's do that, right? I now have formal charge of 0 because of the double bonded oxygen there. Formal charge of 0 there. Formal charge of 0 here. Formal charge of 0 in the hydrogen. And I go to calculate formal charge of nitrogen. 5 minus 0 minus half of the 10 electrons that are around it. And sure enough, I get a 0. So all of them goes to 0. This is amazing. We have figured out the best structure. But unfortunately, this is not the best structure. And you're saying, what? That was in every other case. Well, we can't do that because nitrogen is in second row. It will not exceed the octet. Did it exceed the octet? Yep, it had 5 bonds to it. That means 10 electrons around it. So I cannot do that structure with that. So that's why it's important to know which is your central atom and can you exceed the octet on it? No. So now we're stuck with this structure right here. It is now both a good structure and it is also the best structure. I cannot improve that beyond what's there because I'm locked in to the octet rule for the elements in the second row. They cannot access the d orbitals to put in extra electrons. Locked in, cannot exceed octet. Done.